All right, let's dive into the science behind some everyday things that might make you scratch your head. Things like why does a peeled orange sink? Or how come every single sip of your drink tastes exactly the same? We're going to get to the bottom of it.
Seriously, think about it for a second. When you mix up, say, an ORS drink or even just some juice from a concentrate, that first sip tastes exactly like the last one, right? It's perfectly uniform. How in the world does that happen?
But then, if you try to do the same thing with, say, sand and water, you get a totally different story. The sand just plummets to the bottom. No matter how much you stir, it's not going to mix in. So what's the deal? And then there's this classic puzzle. You can have this enormous, heavy wooden raft floating on the water, no problem. But then you toss in a tiny little pebble, and it sinks straight to the bottom. How does that make any sense? Okay, let's go back to that perfectly mixed drink first. The secret here, the key to understanding this, is something called a solution. It's a special name for what's happening when one thing seems to just vanish into another. So, a solution isn't just any old mixture. It's a perfect mix. It's when the tiny little bits of one substance spread out so evenly inside another that you literally can't see them anymore. And that's exactly why every sip tastes exactly the same. And every solution has two main players. You've got the solute, that's the stuff that gets dissolved, like salt or sugar, and then you have the solvent. That's the stuff that does the dissolving, usually a liquid like water. You put the solute in the solvent and boom, you've got a solution. And this difference is absolutely crucial. In a solution, like salt in water, the salt particles are so tiny and get so mixed in that they disappear. But with sand, well, the grains are just too big and they don't really play nice with the water molecules. So they just drop. One is a true solution, the other is, well, it's just wet sand. Okay, so that leads to a pretty interesting question, doesn't it? If you've got a glass of water, can you just keep dumping salt into it forever? Or is there a limit? You can actually try this yourself. It's super simple. You take a glass of water, add a spoonful of salt, stir it up, gone. Add another, gone. But if you just keep going, eventually you'll hit a point where the salt stops dissolving. It just piles up at the bottom no matter what you do. And that little experiment perfectly shows us two important ideas. When you can still dissolve more stuff, we call that an unsaturated solution. But once you've hit that limit, when it can't take any more, that's what we call a saturated solution. It's completely full. But here's where it gets really cool. What if I told you that limit, that saturation point, isn't set in stone? Turns out you can actually change it. And you probably do it all the time without even thinking about it. It's temperature, for most solids anyway. When you heat up the solvent, the water, it gets way better at dissolving things. That's why you can pack a ton of sugar into a hot cup of tea, but if you try to do the same with iced tea, you just end up with a sugary sludge at the bottom. All right, let's pivot now and tackle that second big mystery we started with. Why does the tiny pebble sink while the giant raft floats? Just like with our solutions, the answer comes down to a really fundamental property of everything. We throw around phrases like iron is heavier than wood all the time. But what do we really mean by that? It's not just about the total weight. What we're actually scientifically talking about is a property called density. So, what is density really? It sounds kind of scientific and maybe a little intimidating. But the core idea is actually super easy to grasp. It's all about how crowded something is. Yeah, just picture a crowded bus. It's packed shoulder to shoulder with people. That's high density. Now picture that same bus with only a handful of people inside. That's low density. See? Density is just a measure of how much stuff is packed into a given space. And the science backs this up. The formula is just mass divided by volume. So our little pebble, it has a lot of mass, a lot of stuff crammed into a tiny little space, or volume. High density, it sinks. The giant raft, yeah, it's heavy, it has a lot of mass, but that mass is spread out over a huge volume. That means it has low density and it floats. And once you get that simple idea, you realize just how massive its implications are. Density literally shapes our entire world, from why ice floats on water all the way to the very structure of our planet. And a big part of that story begins with water.
Believe it or not, it all comes down to a very specific temperature for water, 4 degrees Celsius. This number is incredibly important.
See, at 4 degrees Celsius, water is at its absolute heaviest, its most dense. What's super weird is that if it gets any warmer or any colder than that, it actually starts to expand and become less dense.
Now, this weird quirk becomes massively important when water freezes. As it hits 0 degrees and turns into ice, the water molecules lock into this open, crystal-like structure. They actually spread out. So the amount of stuff, the mass, is the same, but it now takes up more space, more volume. And what happens when volume goes up? Density goes down.
And the result of that? Ice is less dense than liquid water. So it floats. And this is not just a neat party trick. This floating layer of ice acts like a blanket, insulating the water below it. It's what allows all the fish and aquatic life to survive through a cold winter. Without this weird property of water, life as we know it might not even exist.
So once you start thinking in terms of density, you start seeing it everywhere. It's why hot air balloons work. Hot air is less dense, so it rises. It explains why our own planet is layered, with the densest materials sunk to the core. It's how early humans figured out that low-density stuff like bamboo would float, letting them build rafts. Even the oxygen available for fish to breathe depends on temperature and density. It's everywhere.
So let's close out with that puzzle from the very beginning. An unpeeled orange floats, but if you peel it, it sinks. Why? Well, now you know. The peel is full of tiny little air pockets, which drastically increases the orange's total volume without adding much mass. This lowers its overall density, letting it float. Take the peel off, and it's too dense. So, now that you know the science hiding in plain sight, what other everyday mysteries out there can you explain?